The Mars Climate Orbiter mission promised to advance our understanding of Mars' atmosphere, potentially unlocking secrets about weather patterns and climate shifts on the red planet. Unfortunately, the mission is now best remembered as a textbook example of how not to manage interagency communication. The spacecraft was designed and operated by two separate teams using entirely different unit systems. NASA's Jet Propulsion Laboratory worked in metric, while Lockheed Martin engineers used imperial units. This mismatch in calculations, specifically in the spacecraft's thruster force data, was never caught before launch or during critical mission operations. As a result, the orbiter approached Mars at a perilously low altitude, about 57 kilometers lower than planned, causing it to descend into the upper atmosphere where it disintegrated. Millions of dollars, years of hard work, and a significant chunk of America's Martian exploration dreams were lost because someone didn't double-check their math. It's like sending your GPS the wrong conversion factor and then wondering why your vacation car ended up at the bottom of a canyon. This disaster serves as a stark reminder that even in an age of high-tech wizardry, the smallest human oversight can doom a mission. So, when humans again aim for Mars, will they remember the importance of double-checking their units, or will history repeat itself? Apollo 13 began as humanity's next bold leap toward the moon, but the mission quickly morphed into a nerve-wracking game of survival. The explosion of an oxygen tank during the mission wasn't some unpredictable cosmic lightning strike. It was the end result of several risky decisions and overlooked issues back on Earth. Faulty thermostats inside the oxygen tank, combined with damage sustained during pre-flight testing, created a ticking time bomb. Engineers failed to catch these flaws, and when the crew activated the tank, it exploded violently, crippling the service module. The astronauts were forced into a crippled spacecraft, cut off from their planned lunar adventure, and thrust into a desperate struggle to stay alive. With limited power, no heat, and rising carbon dioxide levels, they cobbled together life support fixes with duct tape and onboard supplies. A true cosmic MacGyver moment. For NASA, this was a humbling lesson in the importance of thorough testing, documentation, and redundancy. It's like driving without checking your engine light and then pretending everything's fine as smoke billows from under the hood. The question remains, will space explorers ever fully learn from past oversights? Or will the next forgotten detail send crewed missions spiraling into chaos again? Soyuz 11's mission was historic, the first crewed visit to the Soviet Union's Salyut 1, the world's first space station. The three cosmonauts were trailblazers, orbiting Earth and performing scientific experiments in what was supposed to be a glorious achievement for space exploration. Yet all that promise was shattered during re-entry when a pressure equalization valve opened prematurely. This valve was designed to open after the spacecraft had landed, but a malfunction caused it to vent the atmosphere into space while still in orbit. The cosmonauts were not wearing spacesuits, a critical protocol overlooked because the spacecraft's cramped quarters didn't allow for spacesuit wearing comfortably. Within moments, the cabin depressurized, and the crew suffocated silently in the void without any chance to react. It was a deadly cascade of design shortcuts and procedural errors, a harrowing reminder that space is unforgiving and that every safety margin counts. It's akin to leaving the door open in a vacuum chamber and expecting not to get sucked out. Will engineers adjust their designs and protocols or continue courting disaster with bloated confidence? The Gemini 8 mission was supposed to cement NASA's ability to rendezvous and dock spacecraft in orbit, one of the key skills needed for future moon landings. The operation started smoothly when Armstrong and his crewmate docked with an unmanned Agena target vehicle, a historic first. But then things went sideways. A stuck thruster on Gemini 8 started firing uncontrollably. The spacecraft went into a dangerous, uncontrolled spin that disoriented even an experienced pilot like Neil Armstrong. With the craft spinning at high RPMs, both astronauts feared it might break apart or render them unconscious. Armstrong had to make lightning-fast decisions and use the re-entry control system, meant only for emergency descent to counteract the spin, forcing mission control to abort the mission promptly. The root cause? A faulty switch allowed a thruster to remain active when it shouldn't have, an issue that might seem minor until you realize the spin they experienced was like being inside a washing machine at full speed. This episode revealed gaps in backup planning and redundancy, highlighting that even the best astronauts can be at the mercy of mechanical quirks. So, when the next mission encounters a rogue thruster, will quick thinking be enough to survive, or will that cosmic spin be their last ride? Skylab 4 was an ambitious mission tasked with long-duration space habitation, solar observations, and medical experiments. But beneath the surface of scientific progress, the crew was drowning in work, buried under relentless schedules dictated by ground control. Within weeks, their mental strain built into an unprecedented moment, a near mutiny when the astronauts openly defied orders by switching off communications and taking an unscheduled day off. They had not gone rogue for kicks, but out of sheer human necessity, a desperate bid for sanity in the claustrophobic confines of space with nowhere to escape. Mission control was stunned. The planners hadn't accounted for the full psychological toll of microgravity and non-stop workloads combined with isolation and sensory deprivation. It was a glaring human failure, proving spaceflight isn't just a physical challenge but a psychological minefield. Imagine being trapped in a cubicle without windows or bathroom breaks, and your boss keeps piling on more tasks. Skylab 4 forced NASA to rethink how to treat astronauts as humans, not robots. But what happens when the next crew reaches their limit? Is mutiny the inevitable cosmic rebellion? Apollo 1's story is one of ambition meeting tragedy in the most brutal of fashions. What should have been a routine pre-launch test turned into a funeral pyre when a spark ignited the pure oxygen atmosphere inside the command module. The fire spread with brutal speed, fueled by flammable materials and electrical wiring defects. The three astronauts inside, Gus Grissom, Ed White, and Roger Chaffee, were trapped behind a hatch that couldn't be opened quickly in an emergency. The result was a devastating loss that shook NASA to its core. Investigations revealed countless design flaws and safety oversights that had gone unaddressed despite internal warnings. It was a catastrophic reminder that even space exploration isn't immune to simple yet deadly engineering failures. Like building a paper house and being shocked when it catches fire, Apollo 1 forced a radical rethinking of spacecraft design and test protocols. From this inferno rose improved safety standards that saved future lives. But what if those lessons had been learned too late? Will future astronauts escape the flames of human error? On a frosty January morning, the Challenger shuttle was set for a routine launch, but cold weather masked a sinister vulnerability: its rubber O-ring seals. These rings were designed to keep rocket boosters airtight, but when temperatures drop, rubber loses flexibility, cracking like brittle candy. Engineers knew the O-rings weren't supposed to be used under such freezing conditions and warned NASA repeatedly. However, scheduling pressures and optimism clouded judgment. Just 73 seconds after liftoff, one O-ring failed, allowing hot gas to escape its chamber and fatally damage the shuttle's fuel tank. The shuttle broke apart spectacularly, killing all 7 crew members. This tragedy exposed the deadly cost of ignoring expert warnings in favor of schedule and politics. It's like driving on icy roads with balding tires and praying for no surprises. Challenger's loss changed NASA forever, but the question remains whether organizational hubris can ever be truly eradicated. Will the next mission learn from whispers of warning or drown in denial again? The Columbia shuttle was riding high on success when disaster struck during its 28th mission. During launch, a piece of insulating foam broke off from the external fuel tank, striking the shuttle's left wing with the force of a rifle bullet. Engineers aboard and on the ground recognized the danger. The foam impact could have damaged the thermal protection tiles, critical for safe re-entry. Yet, complacency and tight schedules led to downplaying the threat. Without knowing the extent of the damage, the crew re-entered Earth's atmosphere. The damaged tiles failed under intense heat and friction, causing the shuttle to disintegrate, killing all 7 astronauts inside. It was a heartbreaking reminder that no flaw is too small in spaceflight. Ignoring a broken tile is like ignoring a spiderweb crack on your windshield until it shatters at highway speed. Columbia exposed vulnerabilities in NASA's risk culture, showing how assumptions can cost lives. Will the cosmos ever forgive such neglect, or is every mission a fragile act of faith? Thanks for watching, Space Cadets. If this cosmic roller coaster of astronaut blunders taught you that even heroes mess up spectacularly, hit the comments and shout which failure blew your mind the most. Smash that like button harder than a thruster gone wild, and make sure to subscribe to CosmoBinge for more cosmic chaos. Because space isn't just the final frontier, it's a never-ending blooper reel. Until next time, keep your spacesuit zipped, your wits about you, and your sarcasm ready for liftoff.